And let me start sharing my screen. And let's start over here. Homework 5.8 is due today. Problem set 4 is due by Saturday. Exam 4 needs to be taken by the end of the day Saturday. The problem set final and the final exam need to be done by Wednesday. The final must be done. The problem set final. The final exam itself is optional. If you take the final exam, I will drop your lowest test grade. The last day to play catch up in MyMathLab homework will be Sunday the 2nd, because it does take me a while to go through and look at everybody's assignments and look at what's past, what was done past due, and adjust grades accordingly. In terms of attendance, attendance will be taken on the 3rd, which is Monday, on the 5th, which is Wednesday. I will not take attendance in case people want to use their time in which to work on their exam. I will be available. I'll maybe not on the touch screen, but I'll have Zoom open, and if anybody has any questions, I can be available to answer them. Oh Lord, I misspelled attendance horribly. Okay, we'll just kind of erase the last half of the word. And in terms of Friday, I will not be taking attendance at all. I will not be in, the pen is not working now. I will not be in class. If anybody wants to meet with me, get a hold of me for any reason, let me know by email and I can meet with you. But being you are taking so much time outside of class time for the tests and finals, I figured we probably put in enough time and there's no need to meet on Friday. Does anybody have any questions about any of that? Then next, before we get started with that review for the final, does anybody want to go over any homework questions or problem set questions? Does anybody have questions on any questions? If not, what I had planned on doing today, I could have sworn I had uploaded to the notes copy of the questions from the problem set final. I am not seeing them, so I'm going to just stop sharing for a second and real quick upload those. And I have to apologize. I am not finding them on my thumb drive. Give me a minute. All right. Okay. I'm sorry it took me so long. Okay, so these are questions like the problem set, like what you will see on the final exam. And so I thought that we could start going over them today for the final exam. I am giving you, I believe, 150 minutes because back when the college used to have an exam week, the amount of time that was scheduled for final exams was an hour and a half. And so I've kind of just stuck to that. And so I don't think we'll have time to get through all of this in one class, but we'll see how far we get, and what we don't get through today, we'll go over on Monday. And if there are any questions that you have in your own final problem set, please make sure to bring those on Monday. So again, the final is cumulative. It's made up of questions from the course of, similar to those that were on the 4 preceding exams. So the first question we have here asks us to determine whether the following equation defines y as a function of x. In my mind, there are 2 ways of answering this question. The way that I think is easiest is if you can remember that equation x squared plus y squared equals something, constant. Can anybody remember, if you have an equation with both x and y squared, what the graph of it is going to be? Does anybody remember that as the general equation of, right now the technology is not liking me. The stylus is not working. I'm going to try to, usually when that happens, if I take the battery out and rub it on something, it gives me a little bit more life. Give me a second. Does anybody recognize that as the equation of a circle? When both x and y are squared with the same coefficients, both positive, it becomes a circle. Because there's no h or k, the center is at the origin. But if I look at this circle, do you remember that vertical line test for a function? Here it crosses in 2 places, so it fails the vertical line test, so it's not a function. Since nobody answered, I'm going to go on the assumption that you guys might not recognize that as a circle. In which case, if you don't recognize it as a circle, what you want to do is you want to solve for y. So where I have x squared plus y squared equals 100. Subtracting, I'd have y squared equals 100 minus x squared. And then to solve that, we'd have to take the square root of both sides. And remember, with that square root property, I get 2 roots, a positive and a negative. So y would equal plus or minus 10 minus, plus or minus the square root of 100 minus x squared. And so because of that plus or minus, this tells me that there's 2 y values for every x values, which also tells me that no, it is not a function. Any questions on that one? Can you guys hear me?
Yep.
Okay. That one all right?
Yeah.
Next one then asks us to find the distance between the pair of points. In order to do that, we need to remember the distance formula. Is there anybody who's proud of how well they remember that distance formula? The distance is equal to the square root of the difference in the x values squared plus the difference in the y values squared. And again, that's a formula that you need to know. This first point will be x1, y1. This second point will be x2, y2. And so when I substitute in, the difference in the x values would be 2.3 minus negative 0.7 squared. The difference in the y values would be 8.2 minus 5.2 squared. Remember, when you subtract a negative, it's like adding the positive. So that's the square root of 3 squared, plus this difference would also be 3. So that would be 3 squared. So that gives me the square root of 9 plus 9, or 18. And then it says to simplify your answer. So 18 we can look at as 9 times 2. So in simplest form, that would be 3 square roots of 2. So the exact answer using radicals is 3 square roots of 2. Then to approximate it, we're going to just put that in our calculator. So when I go 3 radical 2 with my calculator, I get to 2 decimal places, 4.24.
Hey, excuse me?
Yep.
Do you know where I could find this handout?
This is just like a copy of the problem set. I didn't insert this into Blackboard.
Oh, man. All right.
But this will be in today's notes. Okay, and your opportunity to do it over and over again would be by doing that problem set final.
All right. Thank you.
Okay. That one all right for everybody? Then the next question asks you to subtract the two fractions. They ask you to select the correct choice below. Fill in any answers in the boxes. Well, I'm going to cross out B because I remember that I have to exclude something. And for what I need to exclude, does everybody remember we exclude values that make the denominator 0? Both those fractions have the same denominator. So I'm worried about what makes x squared plus 6x plus 8 equals 0. Now we've got a quadratic equation to solve. One side is 0. We could go through and use the quadratic formula. We could go through and try to complete the square. I think this one, though, is a pretty easy factor. X squared would be x times x. Because there isn't a leading coefficient, I'm looking for factors of 8 that add to 6, which would be 4 and 2. My signs are the same, both positive. And so setting each of those equal to 0, the first one would give me x equals negative 4. The second one would give me x equals negative 2. Since those values make the denominator 0, they make the fractions undefined. So we know that x cannot equal negative 4 or negative 2. I remember on this test, there was an awful lot of people who struggled with filling in that part of the question. With these rational expressions, with these algebraic fractions, you've got to exclude values that make any denominator equal to 0. Is that part of the question all right?
So you want the denominator to equal 0.
And because it can't, those are the values that we exclude.
Okay.
Now, we're adding these two fractions. They have a common denominator. We like those common denominators, so we're going to keep it. But because it's subtraction, remember that you have to watch your signs. I'm taking that first numerator, x squared plus 3x, and I'm subtracting from it that second numerator, x squared minus 6. Remember, when you subtract polynomials, you have to think of distributing that negative sign. So that actually becomes x squared plus 3x. Negative times x squared would be minus x squared. But then negative times minus 6 would be plus 6 over my common denominator. And now when I combine like terms, the x squareds cancel out, and I'm left with 3x plus 6 over x squared plus 6x plus 8. But I can't stop there because they tell me to simplify my answer. And in order to see if I can simplify that, I need to factor. We already factored that denominator into x plus 4 times x plus 2. When I look at that numerator, does everybody see that there's a common factor of 3? And when I factor that out, what's left is x plus 2. And so I can simplify this fraction by dividing both numerator and denominator by that common factor of x plus 2. So my final answer for the subtraction is 3 over x plus 4. And again, please notice when I decided what to exclude, I had to look at the original denominators. Lot going on there. Does everybody remember those? Does anybody have any questions? If not, let's look at that next question. It again asks us to subtract. And so again, when you subtract polynomials, remember to be careful with your signs. When I do subtraction, the first thing I do is I rewrite it as an addition problem. What's in front of the subtraction stays the same. So that's 3x to the 4th y squared plus 2x cubed y minus 9y. But then remember that minus sign in front of the parentheses. We've got to think of distributing a -1 to everything inside the parentheses, which has a net effect of changing all of those signs. Or -1 times 9 would be -9, and we've got that x to the 4th, y to the 2nd. Negative times a positive would make that minus x cubed y. Negative times a negative would make that plus y. And negative times a negative would make that plus 3x. Is everybody comfortable with recognizing the need to change those signs? Then to do the subtraction, we're going to look for like terms. So first, 3x to the 4th y squared minus 9x to the 4th y squared would give me -6x to the 4th y squared. Then 2x cubed y minus 1x cubed y would give me plus 1x cubed y. Then minus 9y, pardon me, plus y would give me minus 8y. And then there's just that single term of 3x. We can't lose it. So we'll have that plus 3x at the end. And so this would be the answer that goes in that first line. Then you have to remember what the degree is. That term degree refers to the exponents on the variable. If there's multiple variables, remember that we have to add those exponents. So this term would be 4 plus 2, or 6th degree. This term would be exponents are 3 and 1, 3 plus 1, or fourth degree. This term only has the one exponent of 1, so it's first degree. This term only has that one exponent of 1, so it's first degree. So each term has its own degree. We need to remember that for the degree of the polynomial, we take the highest degree of a term. And so this is a sixth degree polynomial. I don't think that's difficult, but I know that sometimes folks get to that question and forget how to find that degree of a polynomial, especially with two variables. Is everybody all right with that one? Not hearing any complaints? Then the next thing that we've got over here is a parabola. We know it's a parabola because only one of the variables is squared. Again, as I look at this, I see that f of x as being y equals the expression on the other side. We want to find the vertex. And what makes it nice is that this equation is in vertex form. Remember that your vertex form is f of x or y is equal to some expression quantity a times x minus h squared plus k. And so in this form, the vertex is the point hk. So the x value of the vertex is what I'm subtracting from x. The y value of the vertex is what I'm adding at the end. So here, if I'm adding 5 to x, that's equivalent of subtracting -5. So the x value of the vertex is -5. And what I'm adding at the end is 7. And so my vertex is the point -5, 7. Please notice that when your equation is in this form, the only work is recognizing that form and determining h and k. Next question shouldn't be too bad because it's what we've been working with. We're asked to take the angle from degrees and change it into radians. In order to do this, you have to remember that pi radians is equal to 180 degrees. So our conversion factor is a ratio of those two quantities. Because we have degrees and we want to change it into radians, we're going to multiply by a conversion factor that has the degrees in the denominator. And the way if we hit a variable, when we were multiplying fractions common to the numerator and denominator, we can cancel it out. We can almost think of canceling those degree symbols out. So that leaves me with -360 pi over 180. They don't tell us to round, and because we're not being asked to round, I would leave it in terms of pi. But I think this can be reduced. I think that we can divide both numerator and denominator by 10. And then I think 9 goes into both 63 and 18. So dividing by 9 gives me -7 pi over 2. And so that would equal -7 pi over 2 radians. How is this first page for everybody? Any questions on any of those? If not, question 7 on this version. And please realize that not all of the problem sets are the same. The questions are pooled. And so take the problem set several times so that you can see all of the possible questions that you might see on that final. This one asks me to multiply. Again, I think there are values that must be excluded. We're going to exclude what makes the denominators equal to 0. So when I said x squared equal to 0, I just get x equals 0. So if x is 0, I have a 0 in the denominator, which doesn't work. So the first value I'm going to exclude is 0. Then when I set that second denominator equal to 0, x squared plus x minus 72, I believe that's also factorable. For x squared, it will be x times x. Because it's negative 72, my signs will be different. Hopefully everybody recognizes that 72 is 9 times 8. And if I have positive 9 and negative 8, they'll add to that 1 in the middle. So then setting each of those factors equal to 0, I'll get, if x is negative 9, the denominator is 0. So we've got to exclude that. And then setting the other equal to 0, I get if x is 8, the denominator is 0, and we have to exclude that. Everybody comfortable with how to fill in this back part? If so, then I remember thinking that these multiplication problems are really just practice factoring and then playing a matchy-matchy type of game. Hopefully everybody recognizes that x squared minus 64 is the difference of two squares. So that'll be x plus 8, x minus 8. Let's leave that x squared alone. When I look at this next numerator, I see that they both have x's, so I've got a common factor of x. And dividing that out, I'll be left with x minus 8. And then we just factored that denominator. We set it factored into x plus 9 times x minus 8. Now, the way multiplication works, we can think of this all as one great big fraction. And any factor of the numerator that matches with a factor of the denominator can be divided out. So they both have a factor of x minus 8. And now here I can put that x into x squared, leaving me with an x in the denominator. And so my final answer would be that x plus 8 times x minus 8 over x times x plus 9. Usually with those, they're perfectly fine if you leave them factored. Instead, if you wanted to multiply it out, that would be x squared minus 64 over x squared plus 9x. But again, you're fine leaving it factored. Is everybody all right with that one? Next question then, we do have a circle, but it's not in that center radius form, which makes it tough to graph. So in order to put that into that center radius form, what we need to do is complete the square. Our equation is x squared plus y squared minus 4x minus 6y minus 12 equals 0. In order to find the center and radius, first we're going to add that 12 to both sides and rearrange that the x's are next to each other. X squared minus 4x, leave a little space, plus y squared minus 6y, leave a little space, equals 12. And then remember, in order to fill in these spaces, we looked at that middle coefficient. We took half of it. Half of -4 is -2. Squaring it would give me 4. So if I add 4 to one side, I have to add 4 to the other side of my equation. In the same way, half of -6 is 3, squared is 9, so I'll add 9 to both sides. So that leaves me with x squared minus 4x plus 4 plus y squared minus 6y plus 9 equals, that sum would be 25. And again, we did that so that this is a perfect square trinomial. That would be x minus 2 quantity squared. Plus, this is also a perfect square trinomial. That would be y minus 3 quantity squared equals 25. And so my standard form is x minus 2 squared plus y minus 3 squared equals 25. If I compare that to that x minus h squared plus y minus k squared equals r squared, the center is hk. So h is what I'm subtracting from x, 2. K is what I'm subtracting from y, 3. And if the radius squared is 25, then the radius is 5. To graph this, I'll go to my center, 2, 3. And then in my labs, you can use that circle tool to go out 5, 1, 2, 3, 4, 5. And that circle tool then gives you just the circle. However, because I'm doing this on a PDF, I'm not quite so lucky. And so I'm going to have to count 5 out in each side and try my darndest to draw that circle. Does everybody remember how to complete the square to find the center and the radius of a circle? Any questions? Vaguely familiar?
Yeah.
Next one asks us to convert the radians to degrees. And so this one, because the radians measure has a pi in it, when that happens, it helps me remember that I'm going to invert that conversion fact and multiply by 180 over pi. Here, the pi's cancel. And so I get 900 over 6, which would be 150 degrees. That one all right? If so, does everybody remember learning about your complex numbers and I, your imaginary unit? Can anybody remember how to divide complex numbers and put our answer in a plus bi form? In order to do this, we want to get the I out of the denominator. And the way to do that is to multiply numerator and denominator by not the same denominator, but rather the conjugate of the denominator. We use the conjugate because it's like, remember when we had a plus b times a minus b, the middle term cancels out and we're left with the first one squared minus the second one squared. So here, my denominator would be 4 squared minus 3i squared. And so that would give me 4 squared is 16. 3i squared would give me 9i squared, but I squared is -1. And so minus a -9 would give me +9. And so right now my denominator is 25. We can use a shortcut on the denominator, but on the numerator we need to multiply those two. To do that multiplication, you can either use repeated distribution, or I know some people like to box. I like to FOIL, so I'm going to, first is h, outer is -6i, inner is +8i, and last would be -6i squared. Remember that I squared is -1, and so that last terms becomes +6. And so 8 plus 6 is 14. Minus 2i plus 8i is plus 2i. So I've got 14 plus 2i over 25. But I'm not quite done because they want it in a plus bi form, where a and b are fractions and lowest terms. They want us to separate the real part from the imaginary part. So separating this fraction, the real part would be the 14, and I have to put that over the denominator. Plus the imaginary part would be the 2i. So we'll take and make a fraction, the 2 over the 25, and then we need to put the I off to the side. Is that one all right? Vaguely familiar? Are you guys remembering all of this? Am I wasting your time, or is this a good review?
This is all right. I know I'm gonna have more trouble with like the word problems.
Okay. Well, here we've got a word problem. It says a telephone pole shown at the top of the, well, shown here is 60 feet tall. A guy wire is 89 feet long, attached from the ground to the top of the pole. We're asked to find the angle between the wire and the pole to the nearest degree. So we're looking for this angle. They put a little right angle in the corner to let us know that the pole is straight and the ground is level. And since that's a right angle, we can use our right triangle trig. This is our reference angle. We know that this side is our hypotenuse. And then in terms of this angle, does everybody see that this other side that we know is next to the angle or adjacent? So using my memory aid, if you need to, adjacent and hypotenuse is cosine. So that tells me that the cosine of the angle is that adjacent leg 60 over the hypotenuse 89. That's all our work. Now remember, to find the angle, we have to first press that second button. Also remember that they want us to find it to the nearest degree. And I can't remember what the last trig was that I did with my calculator, so I want to make sure that it's in degree mode. Please pay attention to that. And so I'm going to press second, then cosine, and that gives me that inverse cosine notation. I'm going to type in 60 divided by 89. And so I get to the, it's an answer 47.611, and it keeps on going. To the nearest degree, I would say that that's rounding up 48 degrees. Is that one all right?
Yeah.
Next question asks us to simplify the expression with something like this. Please remember your order of operations. Going to start with the innermost parentheses. With those innermost parentheses, I don't have like terms. So to get them out of the parentheses, I'm going to distribute the minus sign in front. So I'll have 9 minus 2, and then I'll have 5 minus 9y, and then minus a minus 9 would be plus 9. And inside those parentheses, I can add like terms. So I get 9 minus 2 times in parentheses 14 minus 9y. Then I'm going to distribute that 2, which will give me 9 minus 28 plus 18y. And then 9 minus 28 would be negative 19. So I'm going to write this as 18y minus 19. Is that one all right? Next one, we're asked to solve and check the linear equation. So as I look at this equation, before I do anything, I want to simplify each side. To simplify what's on the left, I'll distribute. That'll give me 2x minus 6 minus 3x plus 6. So that side is negative x. Then when I simplify what's on the right, distributing, I'll get x plus 2 minus x plus 4. And so that gives me 6. And so to finish, we'll divide both sides by negative 1, and I'll get x equals negative 6. For the check, if x is negative 6, this becomes 2 times negative 6 minus 3 times negative 6 minus 2. So let's see, that's 2 times negative 9 or negative 18 minus 3 times negative 8 would be positive 24. So that leaves me with 6. On the other side, I'd have negative 6 plus 2 minus negative 6 minus 4. Negative 6 plus 2 would be negative 4, minus negative 10 would be plus 10. And so I get 6 equals 6, and it checks. Is that one all right? Not hearing any questions. Next one, we're given a polynomial equation. We're asked to solve it by factoring. And here they give us a clue, use the zero product principle. In order to do that, the first thing that I need to do with that equation, let's see, we've got 27x minus 9 equals 3x cubed minus x squared. In order to use the zero product principle, I've got to make one side 0. So I'll subtract that 27x and add that 9 to both sides. And that gives me 0 equals 3x cubed minus x squared minus 27x plus 9. I'm sorry, yeah, plus 9, I apologize. Now we've got this polynomial with 4 terms. Does everybody remember with 4 terms? First try would be to factor by grouping. These first 2 terms have a common factor of x squared. When I factor them out, I'll be left with 3x minus 1. These second 2 terms have a common factor of 9. Because it's negative 27, I'll factor out a negative 9. And when I divide that out of those 2 terms, I'm left with 3x minus 1. At which point I'm going to do a little bit of a happy dance because those have a common factor. So one factor is 3x minus 1. And the other factor would be what remains, the x squared minus 9. And since this is equal to 0, let's finish factoring. 3x minus 1. X squared minus 9 is the difference of squares. So that'll be x plus 3, x minus 3 equals 0. Then, to finish this, when I set each factor equal to 0, the first one gives me x equals 1/3. The second one gives me x equals -3. And the third one gives me x equals 3. And so the solution set is 1/3, -3, and 3. That one all right. Next one asks us to use an identity to find the value of the expression. Don't use a calculator. Oh boy. Well, the angles are the same. That's kind of cool. One is sine and the other is cosecant. Here, what you're expected to remember is that cosecant of any angle, well, that's the reciprocal of the sine of that angle. And so where I have the sine of 49 degrees times the cosecant of 49 degrees, I can think of that as the sine of 49 degrees times its reciprocal, or 1 over the sine of 49 degrees. And because they're reciprocal, that product will be 1. And so in order to do this question, you don't really have to do much work. You just have to recognize that the angles are the same and that the functions are reciprocals. And when you multiply something by its reciprocal, by definition, that product will be 1. Is everybody all right with that one? If so, the next question asks us to solve a radical equation. And it's important with these that we check all of our solutions because sometimes we get that extraneous root. So my equation is the square root of 2x plus 15 minus 6 equals x. On this test, a common careless mistake was that people forgot to get the radical alone first. We have to isolate the radical, get it all by itself. So I'm going to add 6 to both sides. And that gives me the square root of 2x plus 15 is equal to x plus 6. Now, to finish solving that equation, we want to eliminate the radical. In order to do that, we have to do the opposite of taking a square root, which would be squaring both sides. On the left, I'll have 2x plus 15. Because they're inverse operations, it just eliminates the radical. On the right, we've got 2 choices. We've got to remember that if I take x plus 6 and square it, it's like taking x plus 6 times x plus 6. Or we can remember from the work we did with completing the square, that it's the first one squared plus twice the product plus the last one squared. Now, just like before, when we have a polynomial equation with an exponent, we want to make one side 0. So I'll subtract the 2x and the 15 from both sides, which will leave me with 0 equals x squared plus 10x plus 21. Now, I think this one's a pretty easy factor because x squared is x times x. Signs are the same, both positive. 21 is 7 times 3, and that would add to 10 in the middle. Now, the zero multiplication property says that if those multiply to 0, one of the two factors must be 0. So we'll set them both to 0, and we'll get x can be -7, or we can get x equals -3. Again, with these, though, the checks are important. So I apologize. I'm going to scroll way over to the left in the scrap pace here and do my checks. When I check, I have to go back to that original equation. And first, if x equals -7, the square root of 2 times -7 plus 15 minus 6. We want to know, does that equal -7? Well, that's the square root of 1 minus 6, or 1 minus 6 is, oh crap, -5, which is definitely not -7. So we're going to reject that one. And instead, if x is -3, that would be the square root of 2 times -3 plus 15 minus 6. We're hoping that equals -3. Well, that's the square root of -6 plus 15 is 9. The square root of 9 is 3 minus 6 equals -3. And so that one checks. And so while we got two answers to the quadratic that we formed, we see that only one answer works, the -3. If they suggest that you check, it's usually one of those equations where the check is very important, like our radical equations. But we've got to make sure we don't have any of those extraneous roots. That one, all right. If so, the next question says we're choosing between two health clubs. One has a membership fee of $27 and a monthly fee of $29. The other has a membership fee of $17 and a monthly fee of $31. And after how many months will they be the same? What's the total cost for each? Well, we're looking for the number of months. So let's let x equal the number of months. In which case, Club A, we'll call it A of x, we have to pay $27 plus $29 for each month. So that'll be 27 plus 29 times the number of months. The second one, Club B, let's call that B of x. Here, the membership fee is $17 and the monthly fee is $31. So that would give me 17 plus 31x. We want to know when they'll be the same. So let's set those two expressions equal. 27 plus 29x equals 17 plus 31x. Let's get the variables together on one side by subtracting that 29x, and the constants on the other by subtracting that 17. And we get 10 equals 2x. And so dividing, we get that x is 5 months. So in 5 months, the total for each health club will be the same. And now to find what it'll be, we're going to substitute that 5 into our rules. So A of 5 will be 27 plus 29 times 5. Let's see, 29 times 5 is 145. So 27 plus 145 will give me 172. The other club, B of 5, is 17 plus 31 times the number of months, 5, which is 17 plus 155. And so that also gives me 172. So we did something right. They're the same. And after 5 months, we'll have paid, 172 to either club. That's one of those word problems. I know you were saying that, some of you were saying that you were leery of the word problems. Is that one all right?
Yeah.
Good. Next one, we want to find the length of x to the nearest whole number. This is one of those ones where we can think of trying to solve the two right triangles. But please remember there's that one special case where the piece that we know is not a side of either triangle. And we had said when that occurs, we're going to try to find some of the missing angles. And so for this angle, because that's a straight line, I'm going to take 180, a straight angle, minus 50. And I get that this angle here is 130. Then I'm going to remember to find this angle, that 130 plus 25 plus that missing angle, I guess I'll call it y, has to equal 180. And that gives me that missing angle is also 25 degrees. And then remember, if these two angles are the same, these two sides have to be the same. And so this side here is also 370. So we only need to work with this blue right triangle. I'm going to pull it out because I know my diagram's getting messy. In that triangle, we know this is 50 degrees. We know that this side is 370, and we're looking for x. Because it's a right triangle, we're going to use our right triangle trig. So if you need a memory aid, don't be ashamed to write it out. If you don't need it, yay, more power to you. The 370 is our hypotenuse, so we're ruling out tangent. The x is opposite the 50, so we'll use sine, which gives me that the sine of the 50-degree angle is x over 370. I'm going to put this over 1 and cross multiply. 1x is equal to 370 times the sine of 50 degrees. And so now I'll take my calculator, 370. Whoops, it would help if I hit the right buttons. Let's try that again. 370 times the sine of 50. Make sure you're in degrees. I get X is 283.436. They want it to the nearest whole number. And so to the nearest whole number, we'll get 283. And again, I know to use that line of reasoning when the side that I know is not a side of either of the right triangles. Is that question all right? If so, the next question asks us to find the point slope form and general form of the equation of a line that passes through a point and is parallel to this line. In order to be parallel, I have to remember that they have the same slope. And so I'm going to go ahead and try to find the slope of this line. And to find that slope, I'm going to solve for y. So I get 7x minus 9y minus 4 equals 0. Let me add that 9y to both sides. So I get 7x minus 4 is equal to 9y. And then to solve for y, we'll divide both sides by 9. And I'll get y equals 7/9 x minus 4/9. So my slope is 7/9. Because it's parallel, I'm going to keep it. And so my point slope formula is y minus the y value is equal to the slope times x minus the x value. So that would be y minus the y value of my point is 3 is equal to the slope 7/9 times x minus the x value is -8. So that'll become x plus 8. Be careful. There were an awful lot of people who had that written on their paper, but that was not what they put in for this answer. They want this answer in point slope form. So that's all the further we're going to go. To put it in general form, we want everything on one side. So I'll distribute and get y minus 3 is equal to 7/9 x plus, let's see, 7 times 3 is 56/9. At which point I'm gnashing my teeth because of all of those fractions. So I'm going to clear the fractions by multiplying both sides by 9. And I get 9y minus 27 is equal to 7x plus 56. And then if I make the left side 0, I get 7x minus 9y is equal to, let's see, 56 plus 27 is, plus 56 plus 27 would be 83. And so that gives me that 7x minus 9y plus 83 is equal to 0. Quick visual inspection. Because they both start with 7x minus 9y, I know that they're parallel. We could have also gotten this latter equation by using the fact that I know it's going to be 7x minus 9y. And to get that constant, we'll take 7 times the x value of my point minus 9 times the y value of my point, which would give me that negative 56 minus 27, or 7x minus 9y equals negative 83. That'll take me to that same equation. Questions on that one? Can you guys read that, or am I writing too small?
Looks good.
Okay. Have to apologize. Going through school, I always got yelled at as a student for writing too small. So let's try to get one more in before we call it a day. We want to find the measure of the side of the right triangle A. Because it's a right triangle, we know that we can use our trig. So using my memory aid if I need to, we have the two legs. So that means we'll use the tangent. And so I'll have that the tangent of my angle, 39 degrees, is equal to, tangent is opposite over adjacent. So that'll be A over 360. If I put my tangent over 1, when I cross multiply, I get A equals 360 times the tangent of 39 degrees. That's my work. Now I'll take my calculator, make sure that it's in degree mode. Type in 360 times the tangent of 39. And that product gives me 291.5222. And let's see, because that's 0.5, we'll round up to the nearest whole number, is what we're asked for. So that'll be 292. Folks, are these coming back?
Yeah.
Does anybody have any questions on any of the problems that we did? Not hearing any. We got through 4 of the 6 pages. We will finish this on Monday and then go over whatever else you might have questions on, either from the version of the final problem set that you have or anything else. Please remember that Sunday is the last day you can catch up your homework, just the homework in my labs. Please remember that that test 4 and that problem set 4 must be done before the end of the day. Saturday, please remember that it will not count if you don't submit your work. Submit your work. Otherwise, if there are no other questions, well, are there any other questions?